Welcome to Rocky Broad Solar, where we encourage you to make the current flow. On today's episode, we're going to finish up all of the AC and DC wiring in the system here. We're going to go over all of the low voltage connections in the Tigo rapid shutdown system. We're going to commission the batteries, get them charging from the grid for the first time. I just got them charged a few days ago, and sure enough, we had our first power outage. I didn't even know it was on until I walked into the kitchen and saw that our oven display had went off. And that's one of the loads I left here in our non-backed up panel. So it was very exciting. We had about a 5-hour outage and ran on batteries the whole time with no problem. We're also going to kind of go through wiring up the GridBoss. But, you know, I'm going to kind of go over all the little tips and tricks that I've learned along the way, the mistakes that I've made, that I can share with you to make sure you don't make the same mistakes. Alright, so now I'm going to put the DC conductors in. These are the little pressure terminals, so you can kind of jam a little screwdriver in there and kind of pry it up, and it opens up the terminal to terminate the conductors. So we're going to start with PV1. I got an actual screwdriver meant exactly for this. I've got it chiseled down. I've used it on a lot of solar edge projects over the years, but I can't find that at the moment, so I'm using this little screwdriver. You're going to want to be careful that you get all of your little copper strands in there without bending it. And yeah, you want to make sure you give it a little pull test. In this case, we're good. All right. Very close. Out walking with them. Done. All right. I don't know what's going to be easier, pushing or pulling. You want to try pushing first? Okay. Alright, so it's always good practice to put your earth in first before terminating any of your current carrying conductors. Again, I'm just going to snug this down. So I'm going to come back and torque it to spec. So that's our neutral, earth, neutral. Now we've got L1 and L2. Now don't tell anyone I do this, because this is really not a good practice. But I'm using my number 6 strippers for this number 4. And I just go real easy with it to make sure I don't mar up the copper. And once I'm through that shield, I just pull. Alright, and then we've got these fancy little covers to keep yourself from getting electrocuted if you get in here while something's energized and accidentally touch the wrong lugs. It's kind of nice, you don't really see that. Alright, so I'm learning a lot of lessons in this project. It's been like close to 15 years since I was really crimping big 4-aught battery cables. You know, when I first started, we did a lot of off-grid stuff, Outback, Schneider's. But really since then, I've been working with higher voltage batteries and things of that nature. So, I didn't really have the tools to get this done. I had to go order some for this project. First, I ordered this AMZ CNC crimping tool, YQK120. I made the mistake of only getting one that came with 2-aught and 4-aught crimp connectors. Now what I did is I took those out, I put them on the factory crimped cables to test the fit, and it turned out the little crimping dies that came with this crimper did not fit. Now I had a 70, a 95, and a 120. They were stamped 2-aught, 4-aught, and I forget the higher one there. So I was like, well, I should have got the one with 3-aught. So again, if you're gonna buy this brand crimper, you're gonna want to get the one that comes with 2-aught, 3-aught, and 4-aught. I looked all over the internet for replacement dies to where I could just buy some 3-aught dies for it. I thought I found some from another brand. I bought them, and sure enough, they didn't fit. So rather than delay the project more, I just said, you know what, I'll just call it a loss and I'll buy a different brand crimper that comes with the 3-aught size. So I bought this Champ crimping tool. It's actually identical. It's a little bit beefier. It's barely a little bit beefier in a couple dimensions, but it's essentially the same exact tool. So what I would say is if you find Champ YQK120 dies, they would be able to replace this AMZ CNC crimping tool. Anyways, what I'm getting at here is when I got this one, I brought out the 3-aught die, and it was not the right size. And then I started comparing the dies between the two, and the 70 and the 95 dies are different sizes between these two brands. Yeah, so for the 95 that came with the AMZ CNC crimping tool was larger than the one that came with the Champ crimping tool. And so just if you're out there, you're buying these things, I'd say don't trust the dimensions listed on the dies. Instead, what I did is I just took the dies, I lined them up with one of those factory installed crimps right here, and I put the die around that factory installed crimp, and I found the one that was what was crimped by the manufacturer, And I said, all right, that's the size I want. So for this Lichamp one, that would be the one stamped 95. Another mistake that I made when I bought these Degson connectors, I had to get some extra connectors. So again, I couldn't use the factory ones because I had such a long run. So what I did is I bought these 96-inch cables from Signature Solar. They came with a crimped lug on the end to connect to the bus bar, and I said, oh, I'll just cut the other one off the other end and I'd crimp these Degson connectors on there. But what I did is I just ordered 4 Degson connectors. And it wasn't before I got here that I realized, well, the orange connectors are for positive and the black are for negative. And I said, well, who cares? You know, I'll just go ahead and use orange for everything. I mean, it's a black cable. I'm not going to get it mixed up. So I'll just use orange for all. You know, maybe I'll mark it with some black tape, but it's obviously the negative, so I won't mix anything up. But sure enough, these are positive and negative specific. This orange Dexon connector will not physically connect to the negative bus bar on the batteries, which is, you know, to make it foolproof so nobody accidentally reverses polarity in there. But I didn't realize it. So again, here I am another weekend. I don't have the material I need. I'm gonna have to go ahead and cut this crimp off that I just made on this Dexon connectors. These things aren't cheap. I think they're like 20-25 bucks a piece. So that's just, you know, money wasted. Just if you're ordering these connectors separately, making your own crimps, orange is for positive, black is for negative. It's not just a color, it's a physical mating compatibility issue. All right, so here's my Dexon connector. Again, this is positive, can only go on the positive terminals. We're gonna get rid of this Amazon crimper. And we're gonna go with the Lichamp crimper. We're gonna use the Lichamp 95 crimping dice, because that's what matches our factory crimps on these cables. I'm going to use my Klein Tools wire cutter. This thing is awesome. I'd say anybody that's cutting these cables, if you want a nice clean cut, it's well worth it. I'll drop a link in the description below. I'll also drop a link for the crimping tool and the Dexon connectors. Alright, so I'm going to cut off this end with the lug first. If you're getting value out of today's content, do me a favor. Hit the like button, subscribe, press that notification bell, or leave a comment down in the description below. Maybe you've got some advice on what I'm doing wrong here or things you would have done differently. Go ahead and let us know down in those comments. Go. Nice clean cut. I just cut this sheathing off the old school way with an old razor blade. What I do is these actually are pretty deep. They're deeper than just that metal, so I'm going to go ahead and sink that thing about as deep as the threads. Right about there at my fingernail. I'm going to mark it. Very careful. I mean, it looks like I did score the threads just a little bit there, but you know, none of these strands, little fine strands, have broken, so I feel good about it. Next, we're going to thread on this end. Actually, I probably should have done that before I cut the sheathing off. But no harm, no foul. Next, we're going to thread on our Dexon connector. Just be very careful to get all the little threads in there. Voila. All right, so we're gonna put in our 95 die from the Lichamp crimping tool, like so. Next, we're gonna thread in this connector. Now, I looked at the other factory crimps. They're crimping on down towards this this end away from the connector itself, so that's kind of what I'm doing as well. So I'm gonna thread that in there. I'm gonna put the other end of our crimping tool on. I am going to thread this piece on. I'm gonna go ahead and tighten this until it's snug. Alright, so I've got it kind of snugged in there. I don't know if you can see that on the camera. Alright, there, and you can see the die are all the way together. So we've got this crimped down as hard as it's going to get. We're going to turn this little length off and it just kind of automatically opens up. That thing ain't going nowhere. Just slide that up. Tighten our connector down. This provides waterproofing and strain relieving. And there you go. Alright, so I'm going to thread this through. Audible click. This thing was just long enough to make it here. I really lucked out. Didn't really even have an inch to spare. What I did is I ended up moving the long cables to my furthest battery, and that way if I add a third battery in the future, the paralleling cables will go ahead and get it connected. So we're kind of using the middle battery as the leader. I'm just going to snug this down for now. We're going to come back and torque it to spec later in the series. Alright, and just so you can see here, again, this is a factory cable. This is the 95 fitting on the Lichamp tool. You can see it fits like a glove. That's clearly the diameter that they use to crimp this. But I think what we got going on here is that this metal is just thicker than like a standard battery cable, because then when I have a copper lug that I want to crimp, these dies are just too small. I mean, they close seat fully without it being crimped at all. So again, I don't want to give anybody false information here, but it looks to me like depending on the connector or the lug that you're crimping, you may need to change dies even with the same size cable. So what I'm going to do is I'm going to use this 70 die to crimp this copper lug here. So these are the cables that came with it. I am going to put a lug on one end to land on my bus bar, and I'm just going to cut the other end off and throw a little ferrule on there to terminate into the battery terminal. You see that lug fits right on there, but clearly that that 90 die is not going to work on this fitting. All right. Seems like a really nice solid crimp to me. All right, so it looks like none of the heat shrinks were really the size that I needed. This one seems a little oversized, but It's the smallest one that'll fit on this conductor. Hair dryer's not really doing the trick. I'm gonna hit it with a lighter. Alright, doesn't look all that professional with the burn marks on it, but that did the trick. Nothing like some good 1/2-inch Allen sockets if you're doing electrical work. I'll go ahead and drop a link for these in the description below. Alright, so these are some large ferrules. I don't know that they're absolutely necessary. I mean, they're not really, you're not specified to do that in the instruction manual. But I think this will be nice because this wire is so fine stranded, just to make sure we get a nice solid connection there with all the fine strands. I also got these on Amazon. I'm going to go ahead and drop a link down in the description below. Alright, so they're nice and snug. I'm going to come back later, torque them to spec. Alright, so today we're wiring up the Tigo Rapid Shutdown module with the Cloud Connect Advanced here. I could not find a manual specific to the Flexboss, GridBoss inverter combo mixed with Tigo, so I'm going off of the 18K PV Rapid Shutdown instructions. So, a few things to note. I've got my 18 gauge twisted, shielded, 600 volt rated wire going through the conduit from here at the inverter through the conduit with the DC PV power source conductors up to the roof. This is going to connect to the module on the roof, and then at this end it's going to connect to the Cloud Connect Advanced kit. It's very important that it is twisted, shielded, and 600 volt rated. The twisting and shielding is going to prevent cross-contamination or interference of the communication signals from the current carrying conductors. And then the 600 volt rated because it's running in conduit with high voltage DC conductors. So in order for this to be rapid shutdown compliant, we're going to need a secondary rapid shutdown switch out there near the utility meter. That I'm running with just this 2 conductor twisted shielded cable. Now this is not 600 volt rated. Technically it should be, because it's going to be running in this gutter, just one little section. So, you know, doing it by the book. It should also be 600 volt rated, but you know, that stuff's relatively expensive. So what I did is, you know, for that little short run, it's not going to really be in the same conduit fitting or anything. There's, in my opinion, no real danger of it, you know, coming into contact with anything live and high voltage. So the rest of the way from here, or from the Cloud Connect Advanced out to the rapid shutdown switch, it's not going to be running in conduit. It's not going to be running with high voltage conductors. I'm just going to have it either zip tied to the conduit or stapled along the floor trusses to get out there. And then I'm just going to run it externally. So I decided to save a little bit of money and just get some standard 2-wire twisted shielded cable off Amazon for that one. Now I got this little strainer leaf fitting. I've already punched a hole here in the wire gutter. So I'm going to go ahead and start getting some wires pulled around. All right, for this setup, we're not going to need this little power supply or these little jumpers, but I'm going to hang on to them just in case for future, who knows what may come in the future. All right, and here's our 2-wire to get our power supply from the circuit board here in the Flexboss over there to the Tigo CCA. Now you'll see this cable comes with a little drain wire. That is to ground the shield. Now on CTs, you don't ever want to ground the shield, but usually for this communications wiring, you do. So first I'm going to take this little drain wire out of the power supply cable for the CC Connect, and I'm going to ground it. Usually you want to just wrap it around another conductor and terminate it all together, just because it's so small. These terminals aren't really built to land in one of these grounding terminals. So what you'll do is you'll take that drain and you'll wrap it around an equipment grounding conductor somewhere, and then you'll just really wrap it around good there. Land that in the grounding terminal. Alright, so next we're gonna desheath these tiny little power supply wires. And kind of twist them a little bit together so these strands don't get all crazy on us. All right, and these are just pressure terminals, so you just kind of push them in and you put your wires in. I'm gonna actually cut these a little bit shorter. So that we don't have any arcing between our positive and negative wires. So red is going to be positive, black is going to be negative. All right, so I'm going to go ahead and stop here because the rapid shutdown instructions in the 18K PV manual say black is 12 volt negative, red is 12 volt positive, and those terminals are marked that way. Unfortunately, here in the Flexboss, there is no 12 volt negative. All we see is a 12 volt positive and a 24 volt positive. So I don't want to end up plugging this into the wrong terminals and ended up frying something. I'm gonna have to reach out to EG4 and figure out what's going on here. All right, so our positive and negative cables are in. Want to make sure pretty much all the copper is landed inside of that terminal, so there's no chance of arcing or connection between the different conductors. Now, if this were outside, you wouldn't want to do this, but since this is weather tight, so I've still got to get my rapid shutdown switch wired from the auxiliary terminal here in Cloud Connect Advanced. So what I'm going to do is I'm going to drill a hole in the top because I'm going to run that conductor up and throughout the basement. So I just got one of these. I got a big kit of these on Amazon, pretty cheap. I'm going to just run the conductor up through that. While I'm at it, I'm going to go ahead and run a equipment grounding conductor in here to ground this shield. I'm just going to kind of twist these two shields together. The one is just so small, it's very fragile. It's going to be hard to make a really good connection without really just kind of twisting them together and turning them into one. Alright, so I've got the two shields wound together from the two different shielded cables. I've got this equipment grounding conductor I'm bringing into the box. I'm going to just go ahead and throw a little wire nut on it. And I'm going to sneak this equipment ground over into this sub panel to get it grounded. Now we're going to run this wire out to a rapid shutdown switch. Alright, so now we're going to wire up our Tigo Access Point on the roof. This is what, when you hit the rapid shutdown module, triggers the Cloud Connect Advanced to signal the access point on the roof to have the optimizer shut down. I'm going to leave myself some extra cable here. This is going to be mounting on the back of the module. One thing I like about Solar Edge is that you can mount them to the rails. I prefer getting everything mounted to the rails first, everything managed. But with Tigo, you got to do it on the module. So first we're going to get our wire in. This is the only one we need on the roof, so we're not going to be daisy chaining more. So I'm just going to land them in this first terminal block on the left. Alright, so we got our AC run pulled from our AC disconnect into the GridBoss. I'm going to go ahead and connect our equipment ground first. Alright, so we've got our Flexboss wired in. A lot of things DIYers do incorrect here is that you want to leave as little copper coming out of your breakers or your hots as possible, just to prevent arcing or anything like that. Honestly, that one at the top there could have been just a tad bit shorter, but we're going to call that one good. Alright, so now I'm going to pull all of my wire from my non-backup lugs to the non-backup panel, my backup lugs to the backup panel. So I'm going to terminate everything at this end. I'm going to get it all color-coded. I'm going to get a measurement of I'm going to have it in the gutter, get a measurement of roughly what I need to make it into the lugs. I'm going to cut it. I'm going to leave it in the gutter. These panels are live. You know, obviously I don't want to be pulling conductors in there while everything's live. But the whole intention of this is that I'm going to have to cut power when I make that transition from the utility to our main service panel here, from the utility to the GridBoss junction box. And when that happens, I've just learned from experience, things take longer than normal. You end up running into stuff and realizing you're missing a part or a piece. And the last thing you want to do is cut power, cut your utility conductor short, and then find out, you know, it's going to be 8 hours or you're missing something before you can get the power back on. So what I like to do is I just get everything as close as possible to be completely done before I cut power. I'll have all my conductors cut to length and ready so that when I do cut power, it's as simple as just pulling some wire into the panel, stripping it, terminating it, flipping the power back on. Alright, so I was not able to use the factory supplied communications cables because again I wasn't able to stack my inverter on top of the battery banks. So I'm going to have to run external Ethernet cables with crimped ends. So this is a very common failure point in the installation of solar and storage systems. Ethernet cables, the wires are just really brittle. It's really easy to get a bad crimp, and it's really easy to cross your wires. So you just have to really pay attention to detail. Make these little testers as well that you can use to test your cables once it's all done. I'm not sure, mine might have some dead batteries, but I'll double check. orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Clip facing away. Looks like we're good. So this end we're going to plug into the battery comm port in the Flexboss. The other end is going to be over here. Plugged into the CAN port on the wall mount battery. Again, this is the master battery. It's got the number one toggle switch up. The secondary battery's got that secondary toggle switch up. And then this green cable goes from the master comms port over to the secondary battery port. Okay, so here's a little rapid shutdown switch I got off of Amazon. They do make some better ones that were out of stock when I went and ordered this. But essentially, you know, if somebody, a firefighter or someone comes to the house, they want to shut everything down, they come up and they push that button. And that's going to de-energize everything on the roof to low voltage. It's going to de-energize the batteries in this case, with it being an EG4 system. It's just going to make sure that no matter what, everything is de-energized. So this switch is has normally open and normally closed contacts. So what that means is when the switch is disengaged or sticking out, right, that is engaged when you push it, it's disengaged when it comes out. So when it is disengaged, we've got this set that are normally open. You'll see when I engage it, they're closed. So they're normally open when it's disengaged. And then on vice versa, on the other side, we've got some normally closed contactors. So in this case, we're going to run our normally open contactors to the Tigo unit down in the basement. And then we're going to run our normally closed contactors to the EG4 Flexboss21. Now in the Flexboss21, you're going to see a little jumper between two terminals, and again, that is normally closed. It's normally a closed circuit because that jumper just connects the two terminals. And so we're going to connect that to the normally closed contacts in our rapid shutdown switch, so that when we hit it, it opens that contact and it tells the Flexboss21, hey, someone's hit that rapid shutdown switch, do your thing, shut everything down to safe voltage. So in this case, I've got two wire coming in and out. I've got a black and a white. I actually ran out of wire, and they ran out of the wire that I ordered. So I've got the white one heading to the Flexboss. I've got the black one headed to the Tigo unit in the basement. So again, I'm going to connect my white to the normally closed, my black to the normally open. Now, looking back, I didn't really plan this out that well when I ordered the wire. I should have just ordered 4 wire and had it branch off when it got back to the basement, because that way I would have only had to run one single wire from, you know, about 100 feet away in the basement out here to the rapid shutdown switch. Again, you're going to want this to be twisted shielded. You generally only ground this at one end And it's both of these wires are grounded down in the basement, so I'm not going to be grounding this shield out here. Again, finding those closed terminals for the normally closed. And I'm going to run those to the Flexboss. Alright, and so over here at the other end, we've got our 24 volt power supply going to the Cloud Connect Advanced. You'll see I've got the ground connect, or the negative connected to G for ground, the positive connected to the positive 24 because I want to give the Cloud Connect Advanced 24 volts. Now there's no manual currently that tells you how to integrate Tigo with the Flexboss21. And the 18K has different labeled terminals in here. I think they have a positive 12 and a negative 12. So it's a little confusing. This is my best guess. Now, once I flip this on, I could test between those terminals to see if I got 24 volts. But I just wanted to hook it all up before I flip it on. Now over here, we've got our rapid shutdown switch. It replaced this little factory installed jumper. So that is a normally closed circuit with that jumper in there. So we're going to connect the normally closed contacts from our rapid shutdown switch to those terminals. And you'll see that's SW and positive 12. Over here, we've got the power supply coming from the Flexboss going into the power terminal on the Tigos. Here are our wires going up to the roof to the TAP, and then again here are the terminals going out to our rapid shutdown switch to the normally open terminals on that rapid shutdown switch. Now if you want true rapid shutdown with this system, you're gonna have to buy that external switch because you're gonna need that to both signal the Tigos to shut down and signal the Flexboss to shut down the batteries and all that other stuff during a rapid shutdown event. Okay, so the Flexboss is officially commissioned. I've got it charging from the grid just to get it up to 100% state of charge. We're not going to have the solar panels installed till this weekend, and I just wanted to make sure I could kind of play around with all the settings, get the batteries charged up, and just in case we have an outage between now and then, I'm sitting on a full battery bank. Everything seems to be working pretty normal. They've been charging, I don't know, maybe for the last hour or so, and we're already up to 82% state of charge. For some reason, these settings don't seem to take. I've put in the time and date multiple times and hit set. It says that's a success. I've set a bunch of these parameters. Again, it seems to take, and then, you know, you come back 20 minutes later and they all look, you know, as if nothing was ever configured. So I'm not sure what's going on there. I do keep getting this timeout notice, but I'm just not really sure. Alright, the batteries are illuminated. Had them both charged up to 100% from the grid. And this is a couple days after our first outage, which was just in less than a week from the time I got them charged. You'll see they're sitting at 52%. We've got our closed loop communications between the batteries and the inverter. Got the one over here reading 50%. So it looks like for whatever reason they're not perfectly balanced. We're off by about 2%. But I'll tell you, it sure was nice to have these suckers backing up the home the other night when the power went out. If you're a DIYer, go ahead and check out some of our affiliate links down in the description. Might be able to save yourself a little bit of money. If you're not interested in doing it yourself and you'd prefer to hire a qualified installation contractor to give you a turnkey installation, go ahead and down in that description below, check out our Rocky Broad Solar intake form. I've got a few questions. It takes maybe 5 minutes to fill out, and we can schedule a time to get you a zero-cost, pressure-free proposal. Well, thanks so much, everyone, for watching. I really appreciate each and every one of you. Till next time, take care.